Hello friends, thanks for joining this open session on 5G overview and way to 6G. My name is Sanjay Kumar and I'm from Learnizo Global. We have got more than 1000 registration for this session and more than 200 people joined this session on 9th of April 2022. However, if you missed joining this session, we are sharing the video link for your kind reference. If you are watching this video on our Facebook or LinkedIn page, you can look at the first comment to get the complete recording of the session. However, if you're watching this video on our YouTube channel, we request you to like this video, subscribe to our YouTube channel, as well as press on the bell icon to get early notification for all our future videos. Thank you very much, and if you need any further information, please visit www.learnizoglobal.com. www.learnizoglobal.com. Now, these are some of our customers. We work with all major telecom training companies, and we actually train freshers, experienced people on variety of courses. And these are some of our courses. We have courses starting from the business leader, going for the non-tech professional, evolution overview, and going towards the detailed courses of protocols and signaling, network slicing, multi-access edge computing, orchestration, and many advanced topics. These are some of our generic courses. We do a lot of customized courses for a lot of companies on Open RAN, on protocol development, testing, network deployment, and n number of other topics. If you have any requirements, any information required, please feel free to write an email to info@learnizoglobal.com. Most of our offerings are for the corporate companies where they want to train our employees or their workforces on upcoming technologies. My name is Sanjay Kumar, and I'm currently working with Learnizo Global. I'm one of the co-founder in Learnizo Global and NanoCell Networks. But before that, I've worked with companies like HFCL, Reliance Communication, authorized instructor. So there is some problem with the voice. Give me a minute. Let me check. Okay, voice disturbance. Is it clear now, Kuldeep? Can you please confirm? Okay, maybe some network issues. Great. Right. So I got a message from Kuldeep saying that my voice was not clear. So I'm also a certified AWS solution architect as well as an ex-AWS authorized instructor. Now, the big question here is why we are talking about another generation and why we are talking about fifth generation. If you look at the previous generation from 2G to 3G to 4G to 4G, we have already talked about the data rates, higher and higher data rates. So most of our data rate requirements are easily met by 4G network. Then why do we really need 5G? What are the things we are going to achieve with 5G? First of all, it's not only about the user requirement, it is also about the business requirements. Companies are already getting enough business from 4G, but more or less their growth is saturated. They need to grow to make this business, take this business to the next level, and where they need to add more and more users. But almost all the human beings, almost all the people today have mobile phones or one or two connections. Now, how companies are going to grow this business? So companies has to bring in new business areas and new growth perspective to grow their businesses, and that's where 5G comes into play. So 5G is not only for human beings to use some kind of higher data rates, but also about a lot of other things to get connected to the network. And what are those another thing? We will talk about it. So 5G is not going to be just data rate driven kind of network. 5G is going to be driven by the use cases. So there are a lot of new use cases which will be, introduced in 5G, will be fulfilled by some kind of 5G verticals, 5G service verticals, and every network may or may not, suit to those use cases. So we will have a variety of service verticals. We will have something called network slicing, edge computing, and number of other enablers, which are going to fuel the growth of the 5G with these use cases. We are going to talk about so many use cases in upcoming slides, but 5G is not only about human beings. 5G is not only about higher data rate. 5G is going to be driven by many new use cases. Now, why to learn 5G? There are almost 1 million jobs available as per some research, 1 million jobs available on 5G and related technologies. I'm sure you can see around you. There are a lot of people, lot of companies who are looking for 5G skilled resources, 5G cloud DevOps skilled resources. As per some reports of ET, India will need 22 million skilled people for 5G rollouts. Companies are struggling to hire people with these new age skills. So the biggest problem in the industry, especially in a country like India, the problem is not with the manpower. We have abundant manpower. The problem is in the skill and the industry gap. The skills which are required by the industry and skills which are possessed by the people, right? So there is a skill industry gap. And today, almost every company, whether it is a big company, whether it is a small company or a startup, is struggling to hire people. Telecom industry is growing at a fast pace. As per some reports from ET, 5G brings a 30 billion US dollar, and globally it can be much bigger opportunity. So there are a lot of jobs available and lot of scope available for 5G skilled resources. Now, coming back to 5G key enablers. First of all, the first major difference in the previous generation of network and 5G network is cloud native. If we see, most of us are coming from telecom background. Most of us come from telecom background, and we see that most of the networks were some kind of hardware intensive networks. So hardware and software always come as a package, and they were mostly purpose built hardware. They were mostly purpose built hardware. That means they were doing just specific function. However, over the period of time, operators don't want to really continue with that purpose-built hardware. They want to move to some generic hardware, some kind of hardware which is called as COTS hardware, commercial off the shelf hardware. Now, in that also, we want to run these applications, these software, not as monolithic software, but with some kind of microservices, some kind of DevOps, some kind of CI/CD, and that's where we are moving towards cloud native architecture, which is fueled by virtual machines, which is fueled by containers, Docker, Kubernetes, orchestration, and a number of other things. If these words looks alien to you, this is something scary for your career. If you are working in telecom, if you don't know what is cloud native, what is DevOps, what is microservices, what is SDN, what is NFV, what is CI/CD, what is or Docker, Kubernetes, you should know all these things at least at a high level. If you don't know these things, you are actually deceiving yourself. You're not deceiving others, you're deceiving yourself. You should learn these things if you want to work in the telecom world. Cloud native is going to be integral part of telecom world, and we will see the use of cloud native in the telecom network in upcoming slides. The network cannot be micro cells or macro cells, what we used to have in the past. Now we are going with ultra dense network. Ultra dense network is system with different kind of cells covering different areas. So lot of small cells, lot of distributed cells, lot of macro cells, micro cells. Lot of road furniture has to be laid out to support these ultra dense. Maybe after a few years, every street light what you see, or maybe every 10th or every 5th street light, will have one of the small cells covering some of the smaller areas. Massive MIMOs are getting through a lot of transformation. We need to have a lot of antennas for transmission and reception. A lot of smart algorithms has to be brought into the antennas. The use of high frequencies, we are using much higher frequencies. We are using much higher frequencies for our 5G kind of network. So there are something called as FR1, there is something called as FR2, which is referred as millimeter wave, not microwave, millimeter wave. So use of high frequencies in 2200 gigahertz. And multi-access edge computing, we are looking for very, very low latencies, very, very high throughput, which may not be possible in the traditional network. So in many scenarios, we need to bring these user plane resources closer to the end user so that our consumer experience can be enhanced. For public safety verticals, for emergency situation, a lot of device to device communication is also happening. And this is not new to 5G. It has already started happening in 4G itself under release 12, release 13 under the name of MCPTT, GCSC, location-based services, group communication services, mission critical push to talk services. So there are a lot of support for those things in 5G as well. NFV and SDN, network function virtualization and software-defined networking are integral part of upcoming networks. So no network can say no to these things. NFV is all about creating all the applications as VNFs, virtual network function, which we'll discuss later, and decoupling software from the hardware and virtualized network function. Software-defined networking is separating the control plane and user plane. I'm sure many of you have heard about this already called as CUPS, control and user plane separation. And can you please guess, can you let me know in which release we did something similar to CUPS? I'm not saying exactly the CUPS terminology, what we have started using, but just to understand if you are aware about it, can you tell me what is the first time we have started using something? Please listen to this question carefully. Something similar to cups, not cups actually, something similar to cups. What is the first time we did it? Amit says R14. What about others? Do you think the same or something else? What is the first time we did cups, control and usable separation? Something similar to that. Not exactly cups, but something similar to that. Anyone else? If you're not aware, that's okay. Okay, somebody says R10. Okay, Amit, so R10, yeah, you got it right in the reading while we had MSC, which got transformed into MSS and MGW, but the release what you mentioned is wrong. First time we did it in release 4. R4 was the first release where we divided our MSC into MSS, which was divided into two parts. One is media gateway, which is for user plane, and media gateway control function or MSC server, which was typically the control plane. So we divided our MSC into two parts. Control plane was the media gateway control function, and the user plane was media gateway, right? So that was the first time we did it. We did it multiple times. We did it when we moved to release it. We divided our SGS into two parts. One is MME, one is S gateway, but only only towards the radio part of it. We did it again on release 13 when we divided SGW and PGW into control plane and user plane. So there are multiple levels. We try to separate our control plane and user plane. We will not be getting into the details of it, but I just wanted to give a reference to all these things. Now, network slicing. Network slicing is one of the very important aspect of the 5G network. What we are going to do here is we are going to divide one physical infrastructure to create multiple logical networks. Right. So we will divide one physical infrastructure into multiple logical networks, and every logical network can be isolated, can be independent from each other. Many network slices can be standard network slices, and there can be many custom slices as well. So basically, you can sell these slices. You can sell these slices to your enterprise customer. So it is not only focusing on the retail customer, but these 5G networks are also focusing on enterprise customers. So as we see further, we'll see there is something called as 5G private networks. Private network is also picking up pace. So there are a lot of use cases which will be possible only in the 5G private networks. You cannot really meet those, you cannot really fulfill those use cases in the public networks. Public networks are huge. And recently, even AWS kind of companies, they have launched their private network. So you can simply go to AWS website and look for the private network, 5G private network option. So you can simply order a private network from AWS website as well. However, to have all these things, to have cloud native, ultra dense network, massive MIMO, mmWave, MEC, D2D communication, NFV, SDN, and slicing, you are going to need a very, very efficient network management part of piece of it. And that is something which is taken care by orchestration. Orchestration is going to be automation of automation, powered by lot of AI, lot of ML, lot of data analytics. So even AI, ML, data analytics are going to be a critical part of 5G network, whether radio network or the core network. If you are not aware, there is a specific network function which is defined in 5G called as NWDAF. As of now, this is at a very, very preliminary stage, but in future, this is going to be one of the powerful component of the 5G network. The name itself says network data analytics function. So it is going to work in a manner where it is going to become like a brain of 5G core network. So it is going to collect a lot of insights, a lot of data from the network components and feeding that data into some kind of data analytics and giving insights based on that. So NWDF in the coming years is going to be very, very important and critical network function of 5G network. Right. So let's continue our session with the 5G overview. I'm sure you are able to hear me clear and able to, follow me in the discussion. If you have any questions at any point of time, we have over 150, somewhere around 150 participants as of now, which is pretty low number compared to my previous session. And before we continue, my sincere apology for two things. First of all, I originally planned this session for 2nd of April, but somehow I got some personal emergency, and there are some people on LinkedIn saying that I'm getting very unprofessional, but we are all human beings. We can have some emergency at one point or another. So I had got some personal emergency and I have to travel, so could not do this session on 2nd of April. The second thing is when I posted a video, I instead of saying 1900 hours, I mentioned 1700 hours. So these are a couple of mistakes what I done, and we are all human beings. We all make mistakes, and I make more than average mistakes, right? So I really apologize for that. All those two things what I've done, and let's continue with our discussion on the 5G overview. I hope you are able to hear me clearly and able to understand what I'm trying to communicate. At any point of time, if you have any questions, please feel free to type those questions in the chat box. Now, if we look at this picture, this talks about the journey from 1G to 5G. 1G to 5G, we talk about, I'll not talk about the exact years. It came somewhere around 1980s, 1990s, 2000, 2010. And 5G was originally planned as IMT 2020. IMT 2020 means it was planned for year 2020. However, because of some operators push, we have to pre-impone it, and we brought it into the market by 2017. So the first release of 5G is release 15. Release 16 is already frozen. Release 17 is work in progress. And release 18 will not be called as 5G, will be called as 5G Advanced. So a couple of months back, 3GPP has launched a new logo for 5G Advanced. So we are already in discussion of 5G Advanced in release 18. But even 6G may come sooner than expected. So typically earlier we used to say every 10 years we used to have different technologies, but maybe earlier than that we may see 6G in the networks. But as of now, release 16 is frozen, release 17 work in progress, and release 18 is introduced as 5G Advanced. That is one. Second thing here is, if you see the data rate, which started around 9.6 kbps in GSM kind of network, are now projected at 20 gbps kind of data rates in 5G in downlink. For uplink, it is 10 gbps kind of data rate. Now, many people say, hey, we are not even getting 1 gbps kind of data rate in 4G. Now, why there is so much noise about 20 gbps? One thing we need to understand here is all these numbers what are mentioned here are peak data rates. All these numbers are peak data rates. Peak data rates means they are the data rates which are offered by the network. Now, if you are a user and you are one user among hundreds of other users, you are not going to get this complete data rate for yourself. This data rate has to be distributed among the users. So a user may get maybe 1 Mbps, maybe 10 Mbps, but 1 Gbps is the peak data rate of the user. Similarly, 20 Gbps is not the data rate for the end user in 5G. It is the peak data rate, but there is a difference here. In 5G, we are talking about a lot of small cells. We are talking about a lot of small cells, and in some cases, small cells can be your, home E node B, your home G node B, or your femto cell, which is sitting inside your home. And in those kind of scenario, you will be able to enjoy 20 Gbps kind of data rate, not exactly 20 Gbps, but 20 Gbps kind of data rate. Also depending on what kind of UE category you have, also depending on there are some network issues from my side, looks like. So we are talking about 20 Gbps here, and we are facing some network problems here, right? So pardon me for that. I can't really do much with that as of now, right? I hope my voice is clear as of now, right? So 20 Gbps is something which may be available to the end users, may be available to the end users if you are the only customer, you are the only subscriber in that particular set, right? But it is not going to be in a public network. In the open areas, you are not going to achieve this kind of data rate because you will be sharing this with multiple users, right? Another thing here is between LTE Advanced and 5G, we also had something called as LTE Advanced Pro. Now, are we going to see a lot of deployment in LTE Advanced Pro? Today, if you ask your operator who is running a network on LTE, if they need to upgrade their network to LTE Advanced Pro, they may not make that investment. So majority of networks are going to upgrade. Some of the networks may do this upgrade from LTE to LTE Pro, or maybe some of the features, but majority of the operators are going to skip this and directly move to 5G kind of networks. But at the same time, 5G deployments, the initial 5G deployments are not going to be standalone deployments. They are going to be heavily dependent on 4G network, which are typically referred as something called as NSA, non-standalone architecture. Non-standalone architecture, there is a mix of radio technologies between 4G and 5G, Interestingly, first time in the 3GPP history, they are not giving backward compatibility towards 2G and 3G network. They say no compatibility. There are some features which are introduced in release 16, which is called as 5G to 3G SRVCC. But other than this, they don't define any interworking between 2G and 3G because 3GPP as well as the operator want to 3GPP as well as the operator want to, scrap these networks, which is going to get difficult, but they have to do it because the operators cannot run 2G, 3G network, 4G network, and 5G network in the same area. It adds to a lot of costs. It adds to, in some countries like India, up to 65% users are still on 2G kind of networks, which is a very, very big number. But this is going to change in next 2 to 3 years. Majority of these users will be pushed to 4G or 5G kind of networks, right? So this is how the network has evolved. And today, many of the countries, we will talk about it, how many countries have already, started launching 5G services, but many networks, many countries are ready with 5G and they're introducing 5G network services. Now, this is, I'm not going to talk much, GSM and WCDM network architecture, where we have component like BTS, BSC, MSC, GMSC, VLR, HLR, AUC, and 3G network, where we had Node B, RNC, using the same core network. Core network was divided into two paths, CS core, circuit switching core, and PS core, packet switching core. In 4G, when we moved, we have in 5G, we will talk about it. I'll come to your question, right? So in 4G, when we moved, we have completely scrapped our CS core network. So in 4G onwards, it is going to be only packet switching. So in 4G, we typically call this as EPC, Evolved Packet Core Network. However, in some of the older documents, you may see another term called as SAE, System Architecture Evolution, which was later renamed as EPC or Evolved Packet Core. the node B and RNC plugged together, and they are called as E node B. The MME and SGSN was broken in two pieces. One is for MME doing the control plane part of it, and HGW doing the user plane part of it. Control plane, MME, HEW, user plane part of it. The PGW was nothing but something similar to GGSN. So PGW or GGSN can do functionality of each other. The HLR in 2G, 3G is now transformed into something called as HSS. A new node brought in called as PCRF, which typically takes care of the functionality of policy and charging rule function. Right. So this is a quick overview on the LTE-PC network architecture. We'll not talk about it. If you're not aware about these terminologies, if you're not aware about what are these terminology, what are these network components, I have created extensive series of presentation on my YouTube channel where I have talked about all these network components, all the interfaces and their protocols pretty much in detail. So it's a series of around 32 videos. It's a series of around 32 videos which have included all the details about LTE-PC network architecture. If you wish to have a look at it, you can just go to my YouTube channel and look at those videos. So you can also look at the playlist section where I've added all these videos in a playlist as well. Now, if we see the EPC evolution and moving towards the 5G core network. So EPC earlier was MME, HSS, PCRF, SGW, and PGW. However, as I mentioned earlier, we did something called as CUPS in R13, R14, which divided your SGW and PGW in control plane and user plane. Now, you may ask, hey, what is the need of dividing SGW and PGW? And I'm sure many of you have worked with these networks. You will be aware that they are typically one box. Most of the OEMs, when they implement SGW and PGW in the previous generation of network, they typically create them as a single box. They create single piece of hardware. Now, what is the need of dividing control plane and user plane? Can somebody help me to answer this question? What is the benefit of dividing control plane and user plane? Can somebody help me to understand this? Anyone can help me to understand this? What is the benefit of dividing your control plane and user plane? To achieve high throughput may not be the right answer, may not be exactly exact answer. To support the independent scaling, to support independent scaling and to have the distributed allocation of the resources. Now, when your control plane and user plane is separated, it is not mandatory to have all the resources in a central location. You can also bring in some of the user plane resources, some of the user plane resources closer to the end user, especially to meet the requirement of low latency application. As we see further, we will need some application which will require low latency, and that's where we need to bring in our user plane closer to the end user. Now, mapping all these things to 5G network. MME, the more or less MME functionality is brought down to something called as AMF, access and mobility management function, more or less similar to MME, right? The S gateway control plane, P gateway control plane functionality plus some minor functionality related to session management is brought to SMF, which is named as session management function. The user plane functionality here is brought to UPF, which is typically taking care of HGW and PGW user plane. Now, HSS had three different functionality. One is management, another one is repository, another one is authentication. So management part is now done by UDM, Unified Data Management. The repository part of this is taken care of by another network function, which is not shown in this picture, called as UDR, Unified Data Repository. And the authentication part is taken care by AUSF, Authentication Server Function. And there is a difference in the authentication of 4G and the authentication of 5G. In 4G, authentication was done by widgeted network with the support of home network. So typically MME gets all the data from HSS and final decision is taken care by MME. In 5G, we are going to have two levels of authentication. First level of authentication will happen in the widgeted network from the AMF. The second level of authentication will happen in the home network with the help of AUSF. We will talk a bit more about it at a later stage. The PCRF is broken down into two pieces. One piece is PCF, taking care of policy. Another piece is CHF, which is not shown in this picture, called as charging function. So we have separated the policy and the charging function from the PCRF. And that's not all. We have many more network function in 5G compared to this picture. This is just a transition from the 4G, or I'll say EPC, to the 5G core network. In the radio network, architecture wise, there is not going to be much difference. The only difference will be the E node B will be moving into a new name called as G node B, and we will see something called as Open RAN coming up, which will be suitable for all the generation. Many people have this confusion saying that, hey, Open RAN is only for 5G or sometimes only for 5G and 4G. That's not true. Open RAN is valid for all the generation, 2G, 3G, 4G, 5G. But where we are going to have major deployment of Open RAN, are you going to spend money in deploying Open RAN for 2G and 3G network? Of course not. So major deployments are going to happen on 5G, and some of the deployments are also going to happen on 4G networks as well. But it is also applicable for 2G and 3G network. Now, moving on, if we see this picture, core 5G core service-based architecture, we have already talked about AMF, which is typically taking care of function of similar to MME, SMF doing the control plane part of it for session management, UDM and AUSF. This is for data management. This is for authentication. UPF is for the user plane. PCF is for policy management. Even this is not a complete picture. This is not a complete picture. There are many more components to it, but just at a high level, this is the architecture, which is called as service-based architecture. Now, why this is called a service-based architecture? Because now all these network elements, what we were having in 4G, are converted into something called as VNFs, virtual network functions, or CNF, cloud native network function. Cloud native network function. And just for understanding, many people call this as a containerized network function. What does that mean? Now, all these network functions, what you see here, they are not running as monolithic software, but they are running as multiple microservices in the containerized environments, and they are providing those services to other network function with the support of RESTful API, REST APIs. So now, whenever AMF wants to consume some services, it has to send some REST API request to SMF and gets the data. Now, how they really communicate with each other? They communicate with each other using protocols like HTTP2, HTTP2 methods, by using some kind of JSON scripting, right? So they have to be aware about all the network functions which are available in the service-based architecture, and that database is managed by NRF. So NRF becomes like a yellow pages. NRF becomes like a Google for all the network functions to know about other network functions. So the network function who gives the services is called as producer. The network function who consumes the services is called as consumer. Every network function can be consumer. Every network function can be producer as well. We cannot discuss all these detailed things in this session, but typically they are going to communicate with some kind of RESTful API architecture by using HTTP2 protocol in the microservice environments, right? Typically, this is how they will be deployed. So NRF works like a yellow pages for all those network functions. In 5G, we can expose the capability of our 5G networks to the external parties, to the external world by using something called as NEF, network exposure function. Network exposure function. So we can give access to the third party in the controlled environment by using NEF. Right. The next one is NSSF, network slice selection function, which is typically helps the AMF to choose the right AMF to support some kind of slices. So NSSF is not for, typically people get confused with NSSF. They say NSSF is for slice management. NSSF is not for slice management. NSSF is just to enable the core network to choose the right slices for the user or to choose the right AMFs for some particular slices. That is the role of NSSF. UPF, user plane function, is a dumb device, gets all the control from the SMF and provide connectivity towards the data network, DN, which was earlier called as PDN, packet data network. The line above this line, we have the control plane architecture. Below this line, we have mostly user plane architecture. So the service-based architecture is mostly suitable for control plane. But over the period of time, even UPF kind of components are also coming into SBA purview, service-based architecture purview. So the things are changing. And release 17, the recent release, have a very, very different network architecture compared to release 15 and release 16. Right. Now, how we are going to deploy it? So 5G core network, deploying on cloud native architecture, cloud native architecture. If we see this, many of these microservices are deployed on containerized environments by using some Docker containers and Kubernetes, some container orchestration tool, which is also referred as K8s. Now, all these containers are hosting some kind of microservices, and a collection of microservices is one of the network functions. So these network functions are now called as CNFs or containerized network functions. So when you will look at the deployment of 5G, you will see most of these applications, most of those services running with some kind of stateless network functions or containerized network function, which are typically called as cloud native network function, cloud native network function. So this is how we are going to deploy our 5G core network on cloud native environment. Not only this, cloud native will also be suitable for open RAN kind of deployment, for some kind of open RAN kind of deployment. When we will see open RAN, we will see there are something called as XApps, some kind of RApps, right? CU, DU, RU, RIC. Many of these environments are going to be deployed on cloud native architecture. So whether you're working in a radio network or a core network, these containers, these Docker, Kubernetes kind of terminologies are going to be very, very important for you, right? So please go through at least all these details at a high level. Now, moving on. We are going to have multiple service vertical in 5G. We have already talked about it. One of the vertical, which is nothing but higher data rate. Enhanced mobile broadband, which is typically to give up to 20 Gbps kind of data rate and 100 Mbps kind of data rates to the end user. Then there is another service vertical, which is called as ultra reliable low latency communication, which is going to be true millisecond, 1 millisecond kind of latencies, and the reliability of the network is up to 99.999% kind of reliability. Then there is another vertical, which is called as massive machine type communication, which is going to meet the requirement of smart cities, smart homes, and stuff like that. There are another vertical which is defined called as V2X, vehicle to X kind of communication. And there can be a lot of use cases between these verticals as well. So what I'm trying to convey here is, even though we have some standard verticals defined, like EMBB, like URLLC, like MMTC, and like V2X, we can have n number of other use cases which may not fit into any of these, which may require some capabilities of broadband, some capabilities of ultra reliability, some capabilities of massive machine type communication, right? So this is how your 5G networks are going to be use case specific deployments. And most of these use cases, industrial automation kind of use cases may not be able to meet in the public network. So many times we also need to deploy private network. We need to have all these things in some kind of something called as 5G private networks. Yes, we will be uploading this recording on our YouTube channel, and we will be sharing the link. If you have not subscribed to our YouTube channel, you can do that. And as soon as we will upload it, you will get the notification. Now, we can have deployment of 5G network along with the 4G network. So what we have done is we have just looked at two options for core network. One is 4G core, another one is 5G core. In radio network, we have got four options: LT only, NR only, a combination of LT and NR where LT is master, NR is secondary. A combination of NR and LT where NR is master, LT is secondary. Now, two combinations here, four combinations here, we have got 8 options. So these are defined as option 1 to option 8. But out of these 8 options, option 6 and option 8 are disregarded by 3GPP. They say we are not going to work on these two options because that will require to downgrade your G node Bs to work with EPC, and that is not required. So that's why option 6 and option 8 are ruled out. However, option 1 is only 4G. Option 2 is only 5G. Option 3, which requires EPC to work with LT as a master and NR as a secondary, is going to be most important or most popular deployment initially in the initial deployment, and we typically refer this as NSA deployment, non-standalone architecture. Non-standalone architecture means, in this case, just give me a second. Let me get a sip of water. So in this scenario, the NSA deployment, LT is going to be master and going to connect with EPC. NR is just a radio capacity booster. NR doesn't give you a lot of 5G services because 5G core network itself is not present. So it's just acting like a traffic capacity booster in the radio network. So option 3 is going to be one of the most important option, most popular option in the initial deployment if the network is a, the operator is having a 4G network. For a new operator, for a greenfield operator, the only option you will see is option 2. Now, for example, a Dish Wireless, if they don't have a 4G network, they are going to deploy only option 2. Why do they roll out option LT network? They will simply deploy their network on 5G with option 2, right? So it all depends at what level you are and what kind of levels you're trying to achieve. Multiple operator may go with multiple deployment path, or I'll say multiple deployment migrations from one option to another options. Now, as we discussed earlier, our radio network is also opening up. So we have created some standard, new open interfaces. One interface is called as F1, which is typically defined by 3GPP. And another one is called as front haul, which is defined by O-RAN Alliance. So if you are not aware what is O-RAN Alliance, simply you can go to the website. They have all this, just like 3GPP, you have 3gpp.org. O-RAN Alliance have their website as well, where you can download all the standard documents, all the details about. They also have some kind of virtual exhibitions where you can actually visit the stalls of some of the open and vendors and what kind of typical products they are building. So what we have done here is we have divided our base station into two parts. One is called as CU, centralized unit, DU, distributed unit, and RU, which is called as radio unit. Now, all these things can be deployed on a COTS architecture, commercial off-the-shelf architecture, which is typically called as OCloud, Open RAN Cloud. That's not all. We have another intelligent unit sitting on top of that, which is called as REC, Radio Intelligent Controller, which is again divided into two parts. One is called as near RT REC, another one is called as non RT REC, non real-time REC. Right. We are not going to talk about all these things in detail here. We have a specific session on OpenN on our YouTube channel. You can have a look at that session, and that will give you all details related to the OpenN architecture. RIC is Radio Intelligent Controller. Near RT RIC sits closer to these units and gives you real-time control, and non RT RIC sits in the orchestration layer of it and gives non real-time inputs to the near RT RIC. Right. So we'll not talk about all these details here. We have another video covering all those aspects. Now, just a quick comparison. In 2G and 3G, we had hardware-based network elements in the initial days. Later, we have done some kind of changes as well. Dedicated core network, functional entities. We had a lot of proprietary protocols, and these networks were not scalable. In 5G core network, we are moving towards service-based architecture. We are moving towards virtualization, network slicing. We are we are converting our networks into software-based network or cloudifying networks. Application programming interface, all the services are provided by RESTful APIs. Protocols used are HTTP2, HTTPS, JSON-based protocol. We can also provide exposure to the third parties, and we can also, because there is a lot of open infrastructure, open ecosystem available, we can support a lot of backward and forward compatibilities. So we are having a lot of new things in the 5G core network compared to the previous generation of core network. Now, how the next gen deployments are going to be. If we look at some traditional 5G mobile network operator, if you talk about traditional 5G mobile network operator, you will see that the 5G is already having some kind of NFV implementation. So core network is already cloudified. Core network is already cloudified, but mostly doing virtual machines, virtualization. The radio network was still, more or less dominated by some OEMs like Huawei, like Ericsson, like Nokia, where we had a lot of dedicated equipment which are purpose-built hardware, where you can run your DU, use your CU, or maybe your UPF kind of services. The interfaces between DU to RU were mostly proprietary interfaces. Now, what we are doing here is we are actually moving from virtualization to containerization. We are moving from purpose-built hardware to virtualization or containerization, and we are making these proprietary interfaces into open interfaces. And here comes the story of the biggest change maker in the telecom world, Rakuten. Rakuten is one of the company which is leading, which is a torch bearer of many of these things what we are discussing here. Now, what we are doing here is we are moving towards containerized environments. We are building our UPFs on the COD server. We are building our the CU and DU on the COD server. So you are getting this from LTO Star, which is again in now a Rakuten company. And these radios can come from NEC, can come from Airspan, or a number of other companies. Now, this interface is now changed. You can get your DU-CU from different vendor, and you can get your RU from different vendor, because this is a new open interface which is available. And all these things are also deployed on COTS architecture. But again, this will require operators to build a lot of hardware. Now, every operator may not have deep pockets to build those many hardware. So if, let's say, I'm a new operator and want to compete with companies like Rakuten, companies like AT&T, Verizon, or Jio, or Airtel in India, how do I really build my infrastructure? I will not be able to do it because this will require huge investment. And that's where many of the companies are looking for hosting this infrastructure on public cloud infrastructure. And that's where Dish deployment comes into play. Dish Wireless have chosen to go with AWS infrastructure. They say we are going to build our infrastructure on AWS, and they are going to use AWS infrastructure for all these core network, all these CUs and DUs. Now you may ask, hey, core network is okay, CU is okay, but how do I deploy my DUs and the things closer to the radio unit in the centralized cloud? You cannot do it. And that's where AWS has come with a server rack, which is referred as AWS Outpost. So this server rack can typically sit closer to your antenna, can sit closer to your radio units, and can host DU kind of unit, or maybe CU kind of unit, or maybe UPF kind of unit as well, or maybe MEC kind of application. So a lot of stuff can be done by using some server racks from AWS. So AWS is also providing server rack capability to the last mile connectivity, to at the last mile stations. So that's what is happening in the next generation deployment. So a lot of companies like AWS, like Azure, like Google, they are building lot of new applications, lot of new infrastructure to support 5G applications, to support 5G kind of network. And most of the telcos are collaborating with these companies and getting best use of the applications which are available by these public cloud infrastructure companies. Now, what are the things we are going to see in 6G? Now, if we see, we are already at the preliminary stage of 5G. In many countries, 5G networks are the reality, but still in some kind of pockets, in some kind of hotspots. Right. Now, what are the things we can expect in 6G? 6G, as they say, is going to be majorly driven by AIML. AIML is already changing the world. The way we look at AIML is different now. Almost all the telecom networks are now driven by AIML. A lot of cloud intervention, lot of cloud native intervention, a lot of Docker, Kubernetes, DevOps, and number of other stuff. But what are the things we are going to see in 6G kind of network? So in 6G network, we are going to have a segregation of aggregation of different type of network, where we are already talking about the SpaceX, we are talking about OneWeb, right? Where there are a lot of satellite network, unmanned aerial vehicles, terrestrial networks, maritime networks. They're all going to get aggregated and they are going to give you global coverage, right? So now using OneWeb, you can get a satellite internet, right? So there are a lot of new networks are coming in, and in future we are going to get a aggregation of all these networks, and providing global coverage and seamless services. That's what we are trying to target in 6G kind of network. As of now, in 4G we are using sub 6 gigahertz spectrum. In 5G, we have started using mmWave, which is between 24 to 100 gigahertz. In 6G, we are going to use bandwidths beyond that, terahertz or optical kind of bandwidth. So we are going to use lot many new spectrum in the 6G kind of networks. And secure networks, security is going to be another critical aspect even for 5G, because we are moving into more and more the cloud-based network, more and more open networks. So we need to do security at multiple level, at the physical layer, at the network layer, at the transport layer, at the application layer. So even in 5G, we are using TLS between all the network components. We are using OAuth 2.0. But again, this is a very early stage. We may see a lot of security threats where your complete 5G networks, complete 6G network can be hacked by some hackers. So you need to innovate on that. And there are some companies which I'm following which are doing a lot of stuff on the 5G security stuff. So there are a lot of security aspects has to be considered before we move to the next level of the networks. Of course, applications and data are going to be main driver. This has to be driven by AI ML, big data, huge data which is generated by telecom networks, and some data analytics on that, and some deep learning kind of algorithms running on those particular data. Right. So this is what we have in this session. If you want to, if you have joined late, just some quick updates. So if you want to connect to me on LinkedIn, you can do it using this particular link, which is shared in the chat box. You can follow the recording of this session will be uploaded on our YouTube channel. You can download it from, you can view this recording on our YouTube channel. And for real-time updates, you can join our Telegram group, which is with the name of Learn 5G. We are a corporate training company and we provide a lot of training programs to many customers, many leading telecom training companies. And these are some of our offerings. If you need any further information, you can simply visit to info@learnizoglobal.com. Right. So we will not be sharing the slide. And now I'll take up some questions which are, put in the chat box, and then we will take questions from the participants. Give me a minute. Right. So one sec. We have got some questions from Amit. Okay, Amit. So Amit says, what is the current progress of 5G over 5G NR over voice? So Amit, there are VONR specification which are defined, which includes EPS fallback, which includes VOELT and VONR. VONR typically includes the IMS is still in use. In this scenario, 5G core network. Similarly, the way EPC used to connect to 5G IMS, 5G core network can connect to IMS. And now IMS can even sit within your service-based architecture. So one of the application function, which is typically the PCSCF, which is the PCSCF, proxy CSCF, can sit like a application function in your service-based architecture. And IMS can also, in release 16, IMS can also support some features. IMS can support some of the features, something called as IMS slicing. Even IMS can be sliced, supporting multiple types of network. So IMS is pretty much into picture, and it is going to provide voice services even in the 5G network. That's the short answer here. 5G backward compatible with 4G. So Nilesh, yes, you can move from 5G network to 4G network, 4G network to 5G network, and there is a lot of, what I'll say, a lot of reuse of the components. The E node B will be used with G node Bs, and G node B will be used with E node B. So there are a lot of terms what we use. These terms maybe you have already heard. E node B, G node B. Then we have something called as ENG node B. ENG node B is something called as EUTRAN NR dual connectivity. We have something called as ME node B. We have SG node B. We have something called as NGE node B. So there are a lot of different terminologies what we use when we interwork between 4G and 5G network. And I've specifically created a video to talk about all these terminologies and how they're different from each other. So I request you to go through that video and understand what are these different terms, what we are using with E node Bs and G node Bs. Right. Then we have some more questions. Let me have a look at those questions. Okay, there is a question from Amit. Is 3GP defined standard for SBI interfaces for taking each NF over SBI? Do we have predefined SBI REST API format for these communication vendor agnostic or okay? So yes, Amit, there are some open API 3.0 files defined. These are some YAML files which are defined for all the communication between the network functions, and they are all standardized by 3GPP. However, the underlying HTTP methods are typically, they are defined, but the 3GPP doesn't define the standard how HTTP will happen. HTTP is a open ecosystem, and that will follow exactly the same HTTP methods like, put, get, and delete kind of message. They will happen as it is. But yes, open API specification, all these SBI communication, SBI messages using JSON. So these YAML files will have all the 3GPP component written in the JSON scripting, the JSON schema, basically they will be using. And there were some issues. What is NRF and NEF? NRF is NF repository function, which is going to cover, which is going to work like a yellow pages for all the network function. NEF is going to be network exposure function, which is going to expose the network capability to the outside networks or the third party vendors. NWDF and it is not NWSF, it is NWDF, and the network data analytics function is typically going to have a data analytics function within itself. We will not talk much about it now. Okay, so Nilesh says blockchain. Yes, blockchain is also happening in telecom network, but that's a detailed, discussion. We'll not get into it. What is the 1 second. So Mr. Gangadhar says, what is the latency for 5G? Typically, if you see, we say 1 millisecond, but that may not be true for all the use cases. But we are saying in some of the specific use cases, it can go as low as 1 millisecond. But some of the other use cases, even 100 millisecond may be good enough. Right. For MMTC kind of use cases, even 15-minute kind of latency should be good enough, right? So it all depends on what kind of use cases. But yes, the minimum latencies can go down up to less than 1 millisecond. What is service management orchestration? As I talked about orchestration, Saurabh, right? When we were talking about orchestration, we will see that all these things what we are talking about, all these things what we are talking about, which includes MEC, network slicing, SDN, NFV, all these things cannot happen manually. So there has to be very, very beautiful end-to-end service management, and that's something which sits on top of the network, which is typically used. Earlier we used to call this as OSS BSS, but now OSS BSS remains as it is. Between the network and OSS BSS, we have created an orchestration layer, and that's where service management and orchestration is going to sit. And then there will be domain controllers. One domain controller for the radio network, another domain controller for the transport network, another domain controller for the core network, and like that. Okay. What type of protocols? So if you talk about 5G core network, so Manish says what type of protocols we are using in 5G. So in 5G, if you talk about the core network, majorly we are using HTTP2 kind of protocol. If you talk about towards the radio network, if you're talking about the radio network, we typically have a protocol called as NGAP. NGAP is nothing but a protocol similar to S1EAP, what we had in 4G. In the user plane, we have GTPU protocol, which is more or less similar to 4G. Between SMF and UPF, we have a new protocol called as PFCP, Packet Forwarding Control Protocol, which is again came from the cups of 4G network. Right. Sunita says, can we have more insight on 5G private network? Yes, maybe we will try to cover it in some of our future sessions. Where we are using off-one interface. I'm not sure. I'm not sure if you're asking about F1 interface, right? So that's somewhere in the open end. We'll not get into those details as of now. Is the RAN part going to merge in 5GC as we are already going towards cloudification as you do? So that's a question from Pawan. Pawan, yes, there are some efforts happening, and if you see this is specifically talking about it. NG E node B. NG E node B is the E node B of 4G, which is upgraded so that it can connect to 5G core network. So in future, what we may see is we may not see any EPC network, but all the 4G network and the 5G network radio networks can get consolidated in the 5G core network. Second, let me look at some other questions. So there are F1 using Ethernet protocols. That's more related to radio network. Will same orchestrator deploy for 5G core network and Open RAN? This is a message from Amit. Will same orchestrator deploy for 5G core network and Open RAN, or we have standard for ORAN difference between MANO and ONAP? There are a lot of ONAP, ONF, MANO. We cannot get into details of all these things, but yes, there will be a centralized orchestrator, and below that there will be multiple domain controllers. Those domain controllers may be from Open RAN, maybe for the RAN low, RAN high, transport network, and the core network. But there will be a single, centralized layer for the service management layer. Now, with this, we will take few questions from the participants. So if you want to ask any questions, please raise your hands, and then we can, my colleague Kuldeep can unmute you, and then you can ask your questions. Right. If you want to ask any questions, please raise your hands. Okay, Amit have a question. Kuldeep, can you help me to unmute Amit so that he can ask his question?
Yes, hey Sanjay, it was really great session. Thanks a lot. I just wanted to have a quick one, just to addition onto the same query. Whether is that like LCM will be still enabled in case we have a orchestrator, or we gonna replace the LCM lifecycle management?
Okay,
I mean,
so if you see this now, even the life cycle management is going to get more complex with the orchestration coming into play. Now, if you see earlier, life cycle management was for majorly for some kind of applications and some kind of products. Now we need to have life cycle management kind of functionality even for every network slice. So how to steer your traffic, how to create slices, how to manage slices, and how to terminate those slices, right? All these things will come on the lifecycle management. Lifecycle management part is going to be a bit more complex compared to the previous generation. So we have a complete lifecycle management for the network slicing also, complete lifecycle management for the edge applications also, and like that there will be n number of different processes running in the slice management and orchestration part of it. Yeah, thanks, Amit. The next one is from Avdesh. Avdesh, can you, Kuldeep, can you help me to unmute Avdesh? Avdesh, please ask your question. I'm not. Yeah, please go ahead.
Yeah. Hi, Sanjay. My question is regarding the how network slicing will happen in
Okay,
5G.
right.
So
Now, can you please elaborate on a question that will help me to answer your question in right manner?
yes. In the earlier slide, you just showed that there is a different types of use cases will happen. Some use cases require low latency. Some use cases require high bandwidth. Some cases require some connectivity part only. So how cell segregation will happen? Means how we can give these
So
services.
if you
I'll give
see,
us.
now what we need to do is we need to use a layer which is at the slice management layer, right? The orchestration layer, and these slices, these slices are not only the standard slices. There are two types of slices. One type of 1 second, give me a minute. Let me use a pen. There are two types of slices which are defined. Give me a minute. Okay. One type of slices called as standard slices. Standard slices are something which are defined by 3GPP, which will have some basic slices for EMBB, some basic slices for URLLC, some basic slices for MMTC, some basic slices for V2X. It is not mandatory for all the operator to have all these slices. One operator may have only EMBB slice as well. But these are some standard slices which are defined by 3GPP. But then there are some custom slices which are operator defined, right? There can be one slice for police. There can be one slice for, FIFA World Cup. There can be one slice for Indian Railways. There can be one slice for Metro Rail. Like that, operator can create some slices and give those slices on some lease to some of the enterprises, right? That is one way to look at it. Now, how these things will be realized? These things cannot be done manually. So what we need to have is these customers should be able to log in into some kind of customer facing portal, and they can order those slices. That customer facing portal is going to give some commands to OSS and BSS networks. OSS and BSS are going to give some commands to orchestrators, and this orchestrator is going to give commands to some domain controllers. Domain controllers are the controllers for the radio network or the transport network and the core network. And those domain controllers are going to create some specific resources for certain usage. That means typically this will be a complete life cycle, complete cycle of going the requirements from the customer to the network, the piece of the network which will actually going to create these slices, right? So this is a complete big discussion to talk about all these steps one by one, but all these slices will be some kind of logical layers on a single physical network, and they can be completely independent from each other. They can be, there can be radio part can be shared, core network can be dedicated, core network can be shared, radio part can be dedicated. You can even define one frequency. You can even define one frequency to be used in one slice and another frequency which is available in a network to be used by another slice. So you can also define the radio frequencies to be used on individual slices. I hope that answers your question. The next question is from Mr. Lingaraju. Kuldeep, can you help me to get the question from Lingaraju? Mr. Lingaraju, can you please unmute yourself and ask your question? Not sure about it. Let me see. Okay, I'm not sure. There may be something wrong with this audio setting. So I think I was able to, justify your time, what you spend in this session. That's all from my side. We have already, reached to the time limit. It's 8:15 now. Right. I'll request your feedback. If you have any suggestion, any feedback, please connect to me on LinkedIn. If you like my session, if you enjoyed the session, you got something new, some new information, I'll request you to connect to me on LinkedIn and share your thoughts on LinkedIn. Please tag me in the post so that it can reach to more people. That's all from my side. I hope you enjoyed it. Keep in touch and stay connected. Keep learning, right? So learning is the key. If you want to, stay ahead in your career, please keep on learning new things. And cloud and these kind of, terminologies are pretty new to telecom people, but they are very important. Everyone should learn all these things. So I'll request everyone to, stay updated, keep learning new things. And if you need any suggestion, if you need any suggestions, please feel free to send me a message on, LinkedIn. Thank you very much and have a good day. Take care.